An insurance company issues policies covering damage. The amount of damage is uniform 0B. The policy payout is subject to a deductible of B by 10. A policyholder experiences damage. Calculate the ratio of standard deviation of the payout to the standard deviation of damage. So the damage is uniform 0B, let it be X, and let Y be the payout. So fx would be 1 over B minus 0, X between 0 and B. And we want the ratio of standard deviation of Y to the standard deviation of X. Variance of uniform we know is B minus A squared by 12. And it would be B squared by 12. And standard deviation is the square root of variance. So square root of B squared is B, and square root of 12 is square root of 12. And Y is the payout, which is 0 when X is less than the deductible. The deductible is B by 10, which can be written as 0.1B. And the payout is the damage minus the deductible if the damage is between deductible and B, because the maximum damage is B according to the given condition. So E of Y is the integral of Y against the PDF of X. And the reason why we have PDF of X is that we're going to change the Y in terms of X because of this. And Y, so we have non-zero situation when X is between 0.1B and B. And in that case, Y is X minus 0.1B. X between 0.1B and B, and the PDF was 1 over B as we wrote earlier. So fx is 1 over B. And we can write it as X over B, distributing the 1 over B on both these. So X over B minus 0.1. And the integral of this is X squared by 2B minus 0.1X. And when you substitute X equals B, you get B squared over 2B minus 0.1B. And when you substitute X equals 0.1B, you get 0.1B whole squared over 2B minus 0.1 times 0.1B. And now this is B by 2. This is 0.1B. And this one, if you open it out, is 0.01 B squared by 2B. So that would be 0.01 B over 2. And this negative will become plus, and 0.01 B. And all the 4 terms are B terms, so you add and subtract their coefficients, and you end up getting 0.405 B. And that was the expected value of Y, and then we need expected value of Y squared. Remember, we are gearing towards the standard deviation of Y, so that's why we need the E of Y and E of Y squared. So E of Y squared is the same thing. Now we have Y squared integrated against the PDF, and Y between X equals 0.1B and B, Y was X minus 0.1B whole squared. And this one, maybe the easier way to integrate it is not by opening up the square, but just integrate it right away. We don't really need the U substitution here because X coefficient is 1, and it's a linear function of X on which you have a power sitting. So you can just apply power rule to it as if this was just one single variable. So be X minus 0.1 B whole cube by 3. And the 1 over B I pulled out. And the limits are 0.1 B to B. When I substitute the B, I get B minus 0.1 B cube by 3. And when I substitute X equals 0.1 B, then it's a 0. These two become the same. And now B minus 0.1 B is 0.9 B. So 0.9 B whole cube over 3, and this B. And when you open this cube out, it's 0.729 B cube. And 0.729 divided by 3 is 0.243, and b cubed over b is b squared. So that's e of y squared. So now we are in the position to get the standard deviation of y. That's e of y squared minus e of y whole squared, square root. And e of y squared was 0.243b, e of y was 0.405b. So you first square this one, and then you subtract these two, and then you take the square root, and you get 0.281b. And now we have both the standard deviation. So we wanted the ratio of standard deviation of y to standard deviation of x. So standard deviation of y is 0.281b. And remember early on we wrote standard deviation of x was b over square root 12. And that comes, so the b's cancel out and the square root 12 gets multiplied to the 0.281 and get 0.9735. That was choice E.